All right, so back to this Pascal's triangle. We are going to use this triangle, right, to expand or to simplify expressions like this. All right, so we've simplified, some like this where it's to the third power, and it's kind of annoying. All right, what it involved was you'd have to rewrite it as x plus 3 times x plus 3 three different times. All right, and then we had to multiply this part out. So x plus 3, we have to use the distributive property twice. X squared plus 3x plus 9. Then we'd combine like terms, and then we'd have to distribute again. I mean, it takes forever. It really does take a while. Well, if you were to look this process up in a book or online, they would call it the binomial theorem. So let me show you how this is going to work here. So we have x plus 3 to the third power. So the way you can use Pascal's triangle to work something like this out rather simply, and this is the way I want you guys to do it in your, when you're showing me your work, you're going to go down to the third row, all right, of Pascal's triangle. So the one that starts with a 3 right here. Right? And you're going to use these numbers as your coefficients. Now, if it's a 1, you really don't even have to write it. Right? The way it's going to work is you're going to start with this term to the third power. So it'd be a 1. I guess I will write it here. It's a 1, so that coefficient, times x to the third power, like that. Right? And then it's going to be a plus, and then this is going to be our next coefficient here. It'll be a 3, and then instead of it being an x to the third power, it's going to be an x to the second power. And then it's going to be this term to the first power. So 3 to the first power, I guess, if you want to write that. Here, I will write it. All right. And the next is a plus, and then this is going to be our coefficient, that 3. All right. And then it's going to go down by another one. So x to the third, x to the second. This will be an x to the first power. And then the 3, the power of 3 here, is going to go up by 1. So it's going to become a 3 to the second power. And then next, it'll be a plus. This will be a 1, which again, you don't have to write the ones. I'm just kind of trying to show you what's happening here and how it relates. And this will be a 3 to the third power. So first thing to notice here is that your 1, your 3, and your 1, that part just comes from this row. These are going to be your coefficients. And in general, you will not even be putting those ones because those are kind of a waste of space. All right, your exponents, because you were dealing with a third power, each of these terms, that one, this whole term, that whole term, the powers on those, the powers are always going to add up to 3. All right, so on the first one, we had x to the third. On the second one, we had x to the second. But our 3 here, this number was to the first power. And then on our third one, it was an x to the 1. This was 3 to the second. So as the x's, as the powers on the x's descend, 3, 2, 1, the powers for the 3 ascend. All right? There was no 3 at all. Here it's 3 to the first, 3 to the second, and then over here it's 3 to the third, but there's no x at all. All right? And then all we're going to do next is we're going to simplify this expression. So we got x to the third plus, all right, we're going to multiply. This is all multiplication. Multiply your regular numbers. 3 times 3 to the first, that's a 9, and then x squared. And then your next one, we have a 3 times a 3 to the second. Well, 3 to the second is equal to 9, and then 9 times 3, that's equal to 27. And then you have 1x right there. And then your last piece, there's just 3 to the third. So 3 times 3 is 9, times another 3 is 27. And that's your answer right there. So what I'm wanting to see on your work as far as working these out, I'd like to see this step where you're plugging it into the formula per se, and then the third step, the final part, where you simplify your answer. Okay? So instead of having to multiply this out the crazy way, we can apply this little formula. So I'm going to do another one. Okay? 2x plus 5 to the fourth power. All right. So I'm going to go down to the fourth row. These are going to be my coefficients this time. All right. So it's going to be a 1 times the 2x. And notice here, I'm going to wrap that 2x in parentheses like that. It's that whole thing to the fourth power. And then it's going to be a 4. 4 is for my coefficient there. That's from the Pascal's triangle. And then it's going to be a 2x to the third power. So this one's going to go down by 1 times a 5 to the first power. All right. Notice here the exponents, there's a 4, and the exponents here, they add up to 4. Plus, my next coefficient is going to be a 6 right there. Then it's going to be 2x to the second power. And it'll be a 5 to the second power. So you see how the powers here, 4, 3, 2, and then the powers for the 5s are going up. But also notice how the powers add up to 4. That's a kind of the helpful part. Plus, well, I should have wrote sideways here. My next coefficient's a 4. And then it's going to be 2x to the first power. And then a 5 to the third power. Yeah, I'm gonna write like this so that way I have room. And then it's going to be a plus 5 to the fourth power. Okay, so take a look at all your terms. All your terms, they, 4, 6, 4, that kind of matches this part up here. But notice that all these exponents, the pieces, the exponents all add up to 4, or they have a 4 total. All right, last piece, we're going to simplify each of these terms. So 2x to the fourth. What this part means is you're doing 2x times 2x times 2x times 2x. The way that you can think about this is just rewrite it as 2 to the fourth times x to the fourth. You can do that, right? 2 to the fourth is equal to 16. So you get 16x to the fourth. All right, for this one, so we're going to do 4 times 2 to the third times 5. And I'm going to be using the calculator for that one. Maybe not. Ooh, don't have a calculator handy. All right, so here I go. We're doing 4 times 2 to the third. Well, 2 to the third is equal to 8 times 5. All right, 4 times 5 is 20, and then 20 times 8 is 160. So plus 160, and it's x to the third. Okay. And then next, we're going to have 6 times 2 to the second times 5 to the second. Okay, so we've got 6 times 2 to the second is equal to 4. That's that part. And then 5 to the second is equal to 25. All right, 4 times 25 is 100. And then 100 times 6. So we get 600. And then our x's, we got x squared of them. We got 2 of those. And notice the powers should all kind of descend for this. And then next, we're going to have 4 times 2 to the first. So that's 4 times 2. And then 5 to the third. Oh my gosh. 5 to the third is 125. How can I do this? Okay, I see it. 2 times 125 is 250. So I got 250, and I'm timesing that by 4. So that is 1,000. And then x, and then plus 5 to the 4th. I'm just going to pull that out of a hat. It's 625. And that is that. All right, that's going to be our final answer for this example. On the next one, I'm going to do some that involve some negatives. So stay tuned.